Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 16 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2901, longest unequal adjacent groups, subsequence 2. Okay, so let's read the problem statement first. You are given a string array words and an array groups, both arrays having length n. The Hamming distance between two strings of equal length, okay, two strings of equal length, so let's say uh, a and here let's say other string is equal length, right? We need, so here you can say AC. Okay, the Hamming distance between two strings of equal length is the number of positions at which the corresponding characters are different. Okay, so here 0 index, 1 index, 2 index, 0 index, 1 index, 2 index. At 0 index we have a, here also you at 0 index we have a. Okay, here at 2 index we have a, and here also at 2 index we have a. Okay, here the corresponding character at 1 index in these two strings are different, and these two strings are of equal length, so the Hamming distance among them is just 1 because character is different here. Okay, so the Hamming distance between two strings of equal length is the number of positions at which the corresponding characters are different. Okay, so Hamming distance is 1 in this case. Alright, clear? Let's move to next line. You need to select the longest subsequence from an array of indices 0, 1, 2 and minus 1 such that for the subsequence denoted as I of 0, I of 1 to I minus k minus 1 having length k, the following two condition holds. Okay, these two conditions, right? What are these two conditions? So let's read them. For adjacent indices in the subsequence, their corresponding groups are unequal. Okay, so groups of I of j, it should not be equal to groups of I of j plus 1. All right, for each j where j is greater than 0, okay, j plus 1 is greater than 0 and it should be less than k. Okay, so for adjacent indices in the subsequence, their corresponding groups are unequal. Okay, corresponding groups are unequal. Okay, then this is same as the yesterday's problem, right? This condition, right, for adjacent group subsequence 1, right? Okay, so next condition is words of I of j and words of I j plus 1, okay, are equal in length and the Hamming distance between them is 1. Okay, it should be 1, right? Where j plus 1 should be greater than 0 and less than k for all the indices in the subsequence. We have to return a string array containing the words corresponding to the indices in order in the selected subsequence. If there are multiple answers, return any of them. And note that string in words may be unequal in length. Okay, so let's understand these few lines with this example number 1. Okay, so here this is my words string array given to us and groups given to us. All right, so here if you see, if I select this, okay, in yesterday's problem we were implementing greedy approach. Okay, and in yesterday's problem we have groups, I think, in binary form, right? Zeros and ones are there only, right? Okay, but today we can have, I think, 1 to n, right? So here if you see groups of I value 1 to n, right? Okay, so this is one thing. And here let's suppose if I select this first, B A B. Okay, if I select this, then next time can I select this DAB? Tell me, can I select this? So first of all, here both groups are different. Okay, so this condition is like yesterday. If both groups are different, we are picking. But here there is one more thing that we need to check. The words of I, okay, J and this word, they are equal in length. Okay, this is satisfied, equal length. But Hamming distance between them is 1 or not? Let's see. Characters are different. Okay, here characters are same and here also characters same. Yes, Hamming distance also 1. This condition is also satisfied. Okay, so this condition is also satisfied. So this can be our output, right? This can be our output. Okay, so both are valid. Now after that, if I add this, now next time can I add CAB? No, no, both groups 2 only, right? So I can't add. So here if you see output BAB, CAB, and here just see this, another subsequence that can be set is 0, 1. Okay, that is this BAB, DAB, right? Groups 0 is not equal to groups 1, right? both are not equal to 1. All right, see this. And what's 0 dot length is equal to what's 1 dot length, and the Hamming distance between them is 1. So another valid answer is this also. Okay, so it can be shown that the length of the longest subsequence of indices that satisfies the condition is 2. Okay, so we can return any of them, right? So but here we are returning BAB and CAB, and this is also possible now. Both are having different groups, right? And the Hamming distance between them is just 1. Okay, so this is clear, right? Okay, so now here why greedy will fail, in this problem. Okay, so for that let's understand, let's understand this example. Okay, so here if you select this BCB first, if you select this BCB first, okay, like greedy approach that we were using yesterday. Okay, so next time you are going to compare these two. So both are having different groups. Okay, one condition is valid. Then next condition, strings are of equal length. This is also valid. Okay, then third, Hamming distance. Hamming distance is not 1 here. Hamming distance is 3, right? This A, this B, this S, and this A, and this B. Okay, Hamming distance 3. So Hamming distance should be 1 now. So this is not satisfied. Okay, so we can't add this. Then after that we move to this. So I'm going to compare this ACA with this one now. With this one now, BSB. Okay, so as per greedy approach we have to check with this. Okay, previous different group. Okay, so this is not, we are not selecting this. Then I'm going to select this ASA. With ASA also, if you see Hamming distance 3 now, this is also not valid. So your output is going to be BSB as per your greedy approach that we implemented yesterday. But here see, output is this one. Okay, so here greedy will fail. Okay, so what we are going to do here then? So here if you select this group first, this one. Okay, let me just do Control Z. So if you pick this group first, AAA, okay, instead of this one, if you pick this, okay, so after then you can add this now ASA. Both strings are of equal length, both are in different groups, and here Hamming distance 1, only this is different, right? Hamming distance 1, so we can add these two. So output is this. Okay, so this is valid, right? So here we have to find the longest subsequence. Okay, longest subsequence we have to find here, right? So that is why output is this. Okay, so this is little bit related to this problem, longest increasing subsequence. Okay, problem number 300, and I have already solved this problem in my previous videos. Okay, but don't worry, in this video also I'm going to explain this same. Okay, but a little bit fast. All right, so clear why our greedy is failing here, right? So greedy will not work here. Groups are also different, like 2 1 3. Yesterday I think 1 0 1 0 only were there, right? So here we can check now. Yesterday problem, let's go to yesterday's problem. That is nothing but subsequence 1, longest unequal. Yeah, so here groups value is either 0 or 1. Okay, this is also there, and here only one thing we were checking now. We were not checking this Hamming distance and all, that's new. Okay, so we were only checking that groups are different. Okay, in this problem, so this problem is very easy. Okay, simple logic we were using. Whenever there is some different group, then just add that. Okay, but this we are not going to do in today's problem. Okay, so now here clear why greedy will fail. Now here see this example. Okay, this is problem LeetCode 300, longest increasing subsequence. So we have given an integer array nums. We have to return the length of the longest strictly increasing subsequence. Okay, longest strictly increasing subsequence. Okay, so here if you see 2, okay, 2 and 5 is greater than 2, then after that 7 is greater than 5, and then 101 you can select, or you can select it in whatever you want, right? So see, this subsequence length is 4. Okay, you can also select this now. Here you are selecting 257. Okay, you can also select this 237101. Okay, this is also having equal length 4. Okay, so you have to just return the length of the longest strictly increased subsequence. Okay, that is 4 in this case. Okay, so any pattern you can pick. Okay, so how we are going to find out that pattern? Okay, so there is one way. So we are going to use DP. Okay, so here what is the length of this? First tell me. Length of this is 1 2 3 4 5 6 7 8. Okay, so create one DP of length, same length 8. Okay, and create one more array priv. Okay, of same length. Okay, so here I will tell you why we are going to do that. Okay, so here this is let's say this is your DP array and this is your priv array. Okay, so now how I'm going to fill this? Okay, using bottom approach. Okay, so initially I don't know the longest increase subsequence. Okay, so if dp of I, okay, so dp of I is just going to tell me the longest increasing subsequence which is ending at I index. Okay, the longest increasing subsequence ending at I index. Initially I don't know. So initially I will say that if I have just only 10, so only one is longest increase subsequence. Longest increasing subsequence ending at index 1, I will say just that it's only a 9 only. Okay, so only one, size is 1. Okay, I will store the size here, okay, of the longest increasing subsequence ending at index I. So here I will just take 2 alone. Okay, I will just say that this is alone, right? This is the only subsequence, okay, of great length, longest length. So here 1. Okay, so just fill all the values. So longest increase in subsequence ending at index 7 is just 1. Okay, that is 18 only. Longest increase in subsequence ending at index 6 is just 1. That is 101 only. Okay, so initially I have to fill values like this. And in the priv, just fill the values -1. Okay, so right now only single elements we are taking, like 101 only. Okay, so we are not taking any previous value. So here I am just adding -1 everywhere. Okay, so it will just store the previous index that we are going to use to form that longest index. Like here if I'm using 101, so in my longest increasing subsequence before 101 I store which index? I store 7. So I will just pass this index. 7 is at this index, so I will pass that. Okay, so here do one thing, just here just give the indexing. Okay, 0 1 2 3 4 5 and 6 and 7. All right. Okay, so now here how we are going to fill. All right, so first if you pick this 10, okay, so before 10 there is nothing enough, so longest increase subsequence is going to be 1 only. All right, now next time can you pick this 9? Okay, no, we can't pick this 9, right? Because we need strictly increasing, right? So we can't pick 9 after this 10. Okay, but we can just have this 9 now, right? We can just have this 9, right? Only 9. So here give this length only 1, right? And no change, right? Now next time can I pick this 2? No, only I can start from this 2, right? I can only start from 2, right? Before that I can't pick any value because all the values are greater than 2. Okay, and I need strictly increasing, right? So here 1, no change. Now see here, now see here clearly, when my eye is at here, okay, at this position, now my eye is at this position, now I have to run one j loop. Okay, and my j is going to run from this to this. Okay, my I is at this 5 and my j is going to run from this 10 9 to, it is going to check all the elements. Okay, so it is going to try to form the combination, like can I form 10 and then after that can I use 5? Okay, it is going to check this 9, can we use 5 after that, can we use 2 and after that we can use 5? Okay, so this is what I'm going to check here. So yes, here, okay, so here at when my I is at 3, so here I can form this na 2 5, I can form this 2 5. Okay, so here what I'm going to do, if I can form this, so at this 2 what was value, at this 2 the value was just 1. Okay, so in this one I am adding one more element. Okay, so at this 2 I am adding one more value. Okay, so this dp of 2 is nothing but the longest increasing subsequence ending at 2. So in this 2 if I am going to add this 5, right, it is possible na? So I have to add one, this one, and in this one I have to add this next plus 1. Okay, in this one I have to add one more 1. Okay, so this is going to become 2. Okay, this is going to become 2, and here I will store the value of this. Okay, so this is nothing but 2. Okay, this value is nothing but 2 index. Okay, so here I will store 2. Done. This is at 2. All right, so now here next time my eye is going to move forward, next time my eye is going to reach here. Okay, at 4. So now here I will again check. Okay, so again I have to start checking from the start only. Okay, so my eye is at here 4. Now again run loop. Okay, stay starting from this 10. So and 10, can I add this 3? No. After 9 can I add this 3? No. After 2 I can add this 3. Okay, after 2 I can add this 3. Okay, after 2 I can add 3. Okay, so after 2 if I can add 3, so here in 2 we have 1. Okay, the subsequence ending at index this. Okay, at index 2 I can add 1. Okay, 2, after 2 I can add 3. So here ending at 2 is 1, so 1 plus 1, so here I will store 2. Okay, and I will update the previous. Okay, here I added 2. Okay, now after that I move to this 5. Okay, so after 5 I can move I can add 3. No, that is not possible, so that's it. Now after that I will go to the 7. Okay, I will move to the 7. So my I is at 7. Okay, my I is at this 7 index. Okay, this 7 is 5 index. Okay, my I is at 5 index. Okay, my I is at 5, that is 7. Okay, so now here what is going to happen? Now again you have to run one loop. Okay, so here j again you have to run from 10. Okay, so in 10 you can add 7, no. 9 you can add 7, no. In 2 you can add 7. Okay, so in 2 you can add 7. So here the subsequence ending at 2 is 1, and then you are adding 7. So here you are going to update it to 2. Okay, so if you are going to update it to 2, so your this preview is going to update to 2. Okay, because you are using 2. All right, but here say one thing, j is still moving. Okay, so after 5, after 5 also we can add 7 na. So how many what is the size of the subsequence which is ending at 5? So 2 5 na. So here we are storing 2, right? So here at this index 3 we have this na 2 5. So now after this we can add 7 na. So add this size is 2. Okay, at my j, when my j reach here, so add 5. After 5 we can add 7, right? So 2 5 is already there. So now in this 2 if I add 1, so I will get 3. Okay, 2 5 7. So here it will update it to 3. Okay, so 2 plus 2 5 plus 7. Okay, 2 5 and 7, so 3. So now this 5 I am seeing at 3, so this is going to be updated to 3. Okay, this is done. So this is for this. Okay, now after that add 3. So add 3. After 3 also I can add 7 now, right? So add 3. What was the length? Add 3, if you see, that is nothing but 4 index, 4 index. Okay, here also 2 now, 2 plus 1 if I do. Okay, so this was the subsequence now, 2 and 3. Then after that again if I add 7, so again it will remain same 3 only now, so no need to update. Okay, so no need to update here. All right, now after that, once this is done, okay, once this is done, so next after that you are moving to this 101. Okay, so at 101 again you have to run j start from start. Okay, in 10 we can add 101. Okay, in 10 we can add 101. So here 10 is at 0. Okay, in 1 plus 1, so here it is going to become 2. Okay, it is going to become 2 because I am making it like this, 10 and then 101. Okay, so here 10 I have seen at 0 index. Okay, but after this 9 also I can make 101, right? So here 1 plus 1 2, it is going to remain same, no change. Then 2, after 2 also I can add 101, it is 1, and 1 plus 1 2, it is going to remain same. After 5 also I can add 101. Okay, so I am talking here about 2 5 101. Okay, so here at 5 is at 3, so at 3 we have 2 plus 1 3. Okay, and 5 is at 3 index, so here I am adding 3. Okay, this is about 2 5 101. Okay, and then after that I will check this 3. So after 3 also we can add, right? That is not for 2 3 101. Okay, that is also possible. Then again it will remain same length, not 2 3 10, 2 3 101. Okay, then next time my j is going to move here. Okay, at 7. So at after 7 also we can add now. So at 7, if you see 7 is at 5, so at 5 we have 3. Okay, so we have 3 values until 7, like we can use 257 or we can use 237. So after that if I add 101, so it is going to become 4 now. So simple. And dp of I, the longest increase subsequence ending at index 5, is 3, and in this 3 if I add one more element 105, so it is going to become 4, right? So in this 3 if I add plus 1, I will get 4 here, right? So here I'm going to update 4, and here I'm going to update 4, and this 7 is at 5 index, so here I have to update that index. Okay, so here I have to update this index. All right. Okay, now next time 18. So 18 again you have to run one loop. Okay, starting from j. So after 10 you can add 18. So here you're going to update it to 2, and here you're going to update to 0. Then after 9 you are also going to add 18, that is also possible. So again 2, no update. So 2, after 2 you can add 18. So after 5 also you can add 18. Okay, so 2 5 18. So here length is going to become 3, and 5 is at 3, so here you are going to add 3. Then after 7 3 also you can add 18, but there is no change in length. Okay, 2 3 and 18, 3 only. Then 2 3 7, then 18, then it is also possible. So after 7 you can also add 18 now. So 7 is at 5 index, so here you are going to do, here you are going to update 5, and here you are going to update the length as 4. Okay, so 2 3 7 18, you can use that now. So here 4. Okay, so this is done, right? So now that's it now, you come out of this loop. Okay, and you filled all the values. You see the max length here, 4, right? So this is 1 1 1 2 2 3 4 4. So max length that you see is 4, and very first time when you see this max length, that is at index 6. Okay, so what you need to do here, how I'm going to use this priv and the max length logic to form the longest increase subsequence. Okay, so I'm not simply talking about returning the max length. Okay, max length is clear, right? 4 is the maximum, right? So we can simply return 4. Okay, now how we can form this? Okay, so that is a little bit extra of this question, right? How we are going to form this, right? So here max length is 4, and you see this max length 4 for very first time at index 6. Okay, so at index 6, what is the value? 101. Just add that. Okay, if you add this now here, okay, now once this is done, now see at this index 6, what is the previous value, previous index we are using? So previous index we are using is 5. Okay, so go to 5 and print value 7. Okay, at 5 we have added this 7. Okay, now in 5 previous is 3. Okay, so at 3 index, but we have at 3 index we have 5, so add that. Okay, so now you have added at 3. Now at 3, if you see, you go back and you see at 3. Okay, so now you have added this 5 now. So here what is saying, it is saying 2. Okay, so here you at a 2 index. Okay, so this is 1, right? So here 2 is for very first time. So here if you go, so here first you are going to add this 2, then at 2 you are going to see that it is -1. Okay, so that simply means that we have to stop here. Okay, there is nothing. Okay, so that's it. So here just you want to reverse it, you can do that. So you can return 257101. Okay, whatever your choice. Okay, so this is how actually you need to do, right? So if you want to see the DP code, okay, this is just for this problem. Okay, 300. Here I have not added the logic to print the longest increase subsequence, but here you can get the length. Okay, so this is a code for that bottom DP approach. Okay, problem number 300. All right, so now we are going to use the same thing in today's problem also, right? So here also we need the longest part, right? Here if you see in the question, where is that, this, you need to set the longest subsequence for an array of indices. Okay, so we are going to use the same logic that I have explained here, right? And we will check all the conditions like Hamming length, all that stuff we are going to check side by side. Okay, this Hamming distance we will check, right? Strings of equal length we will check, right? And we are going to check the groups also. So here also see BSB, if you select, so in this BSB you can add this after this BSB. No, you can't add, right? You can't add, right? Same way you can't add this ASA. Okay, now here from here AA you can add this. No, because then groups are same. Okay, so only this BSB you are going to return then. Okay, that is the longest length. Okay, so same logic I'm going to write, whatever I explained for this problem, same logic I'm going to write for this. Okay, and I'm going to explain the code also side by side. Okay, so let's write the code and let's understand what we are going to do. Okay, so first before starting, one thing that we need to check the Hamming distance. Okay, so how we are going to check the Hamming distance? So for that I'm writing the function first. Okay, so private boolean check. Okay, and in this we are going to pass the two strings. Okay, string s1, and here I'm going to pass string s2. All right, so this is done, two strings we are passing. And here first of all we have to check the length. Okay, if length is not same, then simply return false. Okay, so s1 dot length. Okay, if it is not equal to s2 dot length. All right, so in that case you have to simply return false. Done. And then after that you have to also calculate the Hamming distance. Okay, so that should not be greater than 1. Okay, that should be equal to 1 only. Okay, it should not be greater than 1, right? So how you are going to check that? So for that purpose you have to write int diff is equal to 0. Okay, and here for run one loop. Okay, so now we know if we don't execute this statement, okay, that simply means that both the strings are having the same length. So here I can simply write I is equal to 0 single loop. Okay, I is equal to 0, I is less than s1 dot length. Okay, and here I can just do simple increment I plus plus. All right, and here I will just check. Okay, so here I will just check if s1 dot character at index I, if it is not equal to the same character at same position, okay, of the other string, then we have to increment the distance. Okay, increment the diff value, right? So here I'm just going to write s1 dot char at index I. Okay, so this is for s1. Okay, if it is not equal to s2 dot char at I. Okay, so here inside this I will just increment the difference. Okay, so plus plus diff I will do. Okay, and I will make sure that it should not be greater than 1. Okay, so otherwise we have to just return false now. That simply means that we can't take these two strings. Okay, and here in the end you have to just simply return true if your diff value is equal to 1, otherwise false. Okay, so this is a simple code for checking the two strings. Okay, now here main code. So here I'm just going to use the same logic that I've explained for the longest increasing subsequence problem. Okay, problem number 300. So here what you need to do, first just calculate the length of groups. Okay, so int n is equal to groups dot length. Okay, so once you calculate this, so it is given that both groups and words are having same length. Okay, you're given a string array words and an array group, both arrays having length n. Okay, this is given, right? So now here after this, create one dp array, same logic, okay, new int n, all right, and then prev, and here also new int n. Okay, and then same logic again, arrays dot fill dp with 1. Okay, dp with 1, and then after that here also arrays dot fill prev with the -1. Okay, I'm filling all the values -1, and take the max index. Okay, variable int max index is equal to 0, and then you have to run two loops, right? Int I is equal to 0, I is less than n, I plus plus, and here after that you have to run one j loop for int j is equal to 0, and here I have told you now, here you can start from I is equal to 1. Okay, right, because at 0 index the only one string will be always ending. Okay, the only length will always be one of the longest increasing subsequence ending at 1 dp of I value, right? So why we need to check. Okay, so here I have told you that j should be less than I always. Okay, and j plus plus. So we were running two loops in case of longest increasing subsequence. Okay, in that problem here I have to check one if I'm going to check these two strings. So here extra, this is extra. Okay, for this problem, words of I, words of j. So here I'm just having distance and all that stuff I'm going to check. Okay, so I'm checking these two strings. Okay, and then once this is done, then after that how we are going to operate the dp of j value and dp of I value. Okay, so here I'm just going to check if dp of j plus 1. Okay, if I add anything in this dp of j, previous string ending at j index, if I add 1 to it and this value comes greater than dp of I, then we have to update the dp of I value, right? Okay, so very simple, right? And here and again check one more condition, groups should not be same. Okay, so groups of I, it should not be equal to groups of I, it should not be equal to groups of j. Okay, this is done. Now here inside this only then you have to update the dp of I. And how you are going to update dp of I? Very simple, dp of j value. Okay, the previous longest increase subsequence ending at j index, in that plus 1 na? Okay, because we are adding that. Now here we have to update prev also. So prev of I am going to update the previous index. Okay, previous where my longest increase in subsequence length was there. Okay, and this is done. And also here we have to store the max index, right? So here how we are going to store, so here dp of I value, okay, whatever the value here in dp of I, am storing the length now. So whenever I get the max length, okay, so it is greater than dp of max index. Okay, right? So here in that case only we have to update the our max index. Okay, so max index is equal to I. So I will store the max index now. So here I was storing the max index. All right, so at 6 index I see the max value. Okay, 4, right? So here I'm storing that. Okay, so this is done. Now this is done. Now only 2-3 lines pending, right? So now just we have to return the answer 9. All the we have to add all these values. Okay, all these words in one string. Okay, so list of string is the output, right? So here I'm just going to write that. Okay, so list, and one second, list, and here inside this you have to write string and name it as answer. Okay, new array list, I'm creating one array list. All right, this is done. Then after that you have to run one for loop. Okay, for int I is equal to, so we are starting from max index. Okay, so max index, and here I should be greater than equal to 0. Okay, if it is -1, stop. Okay, and here also I am going to update with using the prev y. Okay, so in prev y I am storing the previous index that we need to use. Okay, so here how I'm going to update this, first in the answer dot add I'm adding the words of I. Okay, words of I value. All right, So this is done, and now we have to just reverse it, because it is asked that somewhere here mention that we need to return them in order. Okay, so yeah, return a string array containing the words corresponding to the index in order to the selected subsequence. Okay, so I'm going to do the reverse. Okay, because we are starting from the max length. Okay, so here I just do the collections dot reverse. Okay, and collections dot reverse, and here you have to add answer, right? Done. And then you have to just return answer. That's it. Okay, so easy. Right, now let's run the code and see if there are any code issues. We'll try to fix that. So yes, there are some issues, so let's fix that. Okay, so here a same string, why I'm taking is as2 now. Okay, let's run it again. So again there is some issue, so let's fix that. This for loop is ending here, and here this should end here completely. Okay, and here once you add this here, this should not be here then. Okay, so now here let's do one thing now. Let's just format the code. Okay, and now let's run it and let's see. So now see, all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.